We continue on into the second of 3 lectures in Chapter 8. This one concerned with the other Jovian moons, starting with Saturn and going on to Uranus and Neptune. Focusing on Saturn, the latest update is that Saturn itself has as many as 62 moons. Most of the moons discovered in the recent years, and this is almost double the number that was just a few years ago. Most of the moons are small, Titan being Saturn's only large Jovian moon. Here's a mass comparison of Saturn's moons. All the orange here is the mass of Titan, and we have this little blue here, which is Rhea, and this blue over here, which is IAPETUS. So after a few of the medium-sized moons, the purple being DIONE and the green being Tethys, as we look at those medium-sized moons, there's not much left, just that little sliver right there for all other moons. So you have Titan being the large moon, most of the mass of the Saturnian system, and then you have some medium-sized moons, and then all the other moons are just little rocks. Titan is Saturn's only large moon. It's about twice the mass of our moon. It's the second largest Jovian moon, second largest moon in the solar system. And this picture was taken by Voyager 1. Voyager 1 was part of the Voyager 1, Voyager 2 investigation. And Voyager 1 was sacrificed, pulled away from Saturn, and pulled away from its mission to look at the other Jovian planets to take a good look at Titan, because Titan was very interesting. So Voyager 1 snapped this picture of Titan, which is kind of fuzzy and didn't really show much, before it went perpendicularly out of the solar system after that. And Voyager 2 continued on within the ecliptic plane to look at the other Jovian planets. Here's a look at Titan taken by Cassini of different wavelengths. You got visible, infrared, and a composite, kind of showing a little bit of the atmosphere effects. Here's a composite look from Cassini. Now you can see a little bit of the atmosphere on the edge here. Here's even more enhanced, and you can see more atmospheric effects observed by Cassini. Surface temperature of Titan is 94 degrees Kelvin, pretty cold. It's likely to have methane rain and or ethane oceans. Believed to have a chemistry similar to a pre-life Earth, so it is one of those places in our solar system that is very interesting to exobiologists, even though it's very likely, almost 100% likely, that there is no life on Titan. But it's got conditions of a primordial Earth, so it would be interesting to study as a place where life possibly could occur way off in the future. Here's a closer look at the atmosphere taken by Cassini. It's observed of the haze. Atmospheric pressure on Titan is 60% greater than that on Earth, so it's 1.6 atmospheres of pressure, comprised of 90% nitrogen, 10% argon. Our atmosphere is 80% nitrogen, and argon being the third most common gas in our atmosphere. So at one time we probably were 90% nitrogen and argon after that. So very similar to an Earth atmosphere. And traces of methane. Methane is believed to condense in methane clouds and rain down onto the surface of the moon. Thickness of the atmosphere is up to 10 times the height of the atmosphere on Earth. So it's got 60% more pressure and much more height to the atmosphere. Let's now look at the atmosphere. Gravity on Titan is only 1/7 that of the Earth, so it's got this greater atmospheric pressure, much less gravity. Hence, if you were on Titan, it would be easy to fly. In other words, if you could make yourself some wings, you could fly around in the atmosphere of Titan with no problem at all. Here's a picture taken by the Huygens probe as it descended onto Titan, so we could see that there does appear to be lakes of something, most likely methane, and there's a shoreline to those bodies of liquid. The mantle of Titan might be slushy water like Ganymede. Here we can see more of this kind of liquid system on Titan. Drainage system, if you will, showing very large drainage system and capillaries to that. So you have fluid-carrying rivers with tributaries and a denser network, indicating that there is indeed a mechanism of rainfall and liquid flow on the surface of Titan. And evidence of a volcano on Titan. What type of volcano, we don't know. Here's an infrared picture showing possible internal heat source on Titan, the cause of which would be unknown. Could be gravitational flexing, similar to what's occurring on Io. Hard to say. Some interesting surface features as you look at Titan. This surface, if you were to expand it out and look at these features, it already has some dark areas, which might be attributed with a little bit of imagination to some figures. If you spread this out like a Mercator projection, here are some provisional names. You have the line down H over here. You have the ball. You have the dog. And chasing the dog, you have the dragon's head. So these are just names given to these dark areas on the surface of Titan. And you have Xanadu, which is the bright area down here. Here's some other Saturnian moons: IAPETUS, Mimas, Enceladus, Tethys, Dione, and Rhea. Rhea being the second largest moon of Titan. They're all classified as medium size: Mimas, Enceladus, IAPETUS, Tethys, Rhea, and Dione. Here's Dione and Tethys. In comparison to Saturn, much smaller than the host planet. Radii between 200 kilometers and 800 kilometers. Composed of rock and ice. So this is about 120 miles to 500 miles in diameter. Composed of rock and ice. Heavily cratered. All these moons heavily cratered. They all orbit Saturn in circular, tightly locked orbits, always showing the same face towards the planet, because the planet's gravity is large enough to keep them tightly fixed, like our moon around Earth. Here's a great picture showing Titan and the shadow of Titan, but you can see some of the other moons near the equatorial plane of Saturn. And in fact, if we were to extend these moons going around Saturn and look at them in particular, starting from the ring system, focus in here at the F ring where Prometheus and Pandora exist, and Janus and Epimetheus over here in this outer ring system. Here's a picture of Prometheus within the ring system. Near the F ring, you can see some of its effects on the ring, gravitational effects creating a wave-like nature within the particles of the ring. Here's Prometheus. Here's Epimetheus. Epimetheus was the fellow in mythology who was always forced to look backwards because he had been telling the future, and now he was forced to always look back. Here's Pan, and here's a little animation of Pan moving through the Saturnian ring system. Kind of a neat little animation here. Moving a little bit further out, you got Mimas. Here's Mimas against the Saturnian ring system, and actually digging out a path which is called the Cassini division in Saturn's rings. So it's a gap all the way around in Saturn's rings occupied by Mimas. So Mimas is responsible for that gap. It takes 22.5 hours to revolve around Saturn, and it's tidally fixed, so that's also the length of Mimas' day. And this photo was taken by Cassini in 2005. Here's a closer look at Mimas. Another close look at Mimas, color enhanced over here. And you can see that there's a very large crater in Mimas. In fact, a crater so large that the impact might have been close to destroying the moon. So almost split the moon in half. The crater is named after Herschel, the discoverer of Uranus. So if you do something great in astronomy, you too could have a crater named after you. As we move further out, we have Enceladus near the E-ring, or in the E-ring of Saturn. We've talked about Enceladus briefly before. We have the tiger stripes down here to the south here, and known to have these icy volcanoes, these water geysers that put out snow that either rains down onto the moon or out into Saturn's E-ring. So it's fueling the production of Saturn's E-ring. Enceladus has this icy snow, which is causing a diffuse reflection all over the moon, making it the most reflective object in the solar system, reflecting nearly 100% of the light on it. If we look closer at the surface of Enceladus, we can see some of the tectonics that we've seen on other icy moons, grooves, and in this case, some crater impacts as well. Some very interesting grooves here, similar to what we saw on Ganymede, but unknown. If we really look at the surface here, taken by Cassini, we can see boulders on the surface from 10 to 100 meters in diameter on the surface, ice boulders on the surface of Enceladus, and you can see some of the patchwork tectonics as well as what we saw in general from a greater distance. The tiger stripes, the sulci on the surface of Enceladus. Here's infrared showing that indeed something is going on there at these tiger stripes. In fact, these rifts across the surface have been called sulcis, and named after Alexandria, Cairo, Damascus, and Baghdad, ancient key cities called sulcis. Here's the Damascus sulcus. And through these rifts is where the water geysers are spewing out their water and their snow. So a lot of tension going on there at this point on the surface of Enceladus. Here's a picture of those geysers emitting out into space. So evidently there's liquid water on Enceladus, making it, as we said before, one of the key places to look for the possibility of life. Anytime you find liquid water, internal heat source, you imagine that there is the possibility that life could be there. So a very interesting place to exobiologists. As we said before, it's a relatively small moon, just about the size of Alabama. As we move further out, we have Tethys. Has a very old terrain, showing all sizes of crater impacts, basically proving that it has one of the oldest surfaces in the solar system, like Callisto. 4.6 billion year old ice on its surface. So it would be a good place to visit if you want to investigate unchanged surface from the beginning of the solar system. Closer look at Tethys. And we have these crater system here. We got some groove terrain over here. It was very interesting what might be the cause of that. Move further out to Dione. Here's Dione against the backdrop of Saturn itself. Closer look, a beautiful picture from recent Cassini picture. And even more detail from Cassini. You can see a very battered surface. You got these grooves here, craters. You got some rays from impacts and material falling back down to the moon. A little bit more clear here. Impact over here and some ray material here. Very nice. Rhea, the second largest moon of Saturn, but much smaller than Titan, and the medium-sized moon, also showing rays and impact in the ejecta from a meteoric impact causing a crater and spewing out the material. A little bit more of that effect here on this picture. Wispy terrain. Real close look at the surface of Rhea in recent pictures, and also showing a collage of many impacts, proving that it too has a very old surface. Moving further out from Saturn, we have other moons. Here's Hyperion. There's a little icy rock out there. Small moon with erratic rotation. Here's IAPETUS, Saturn's third largest moon. Has a high-low orbit out of the ring plane with a leading dark side and a lighter trailing side. So even so, it's still tightly fixed to the planet. So as it goes around the planet, it always shows the same face towards Saturn, and that face is two-faced, because its leading edge is darker than its trailing edge, likely because it's picking up material that is darker in the space around Saturn. Kind of reminds me of an episode of Star Trek where the two competing and fighting races were one side of their face was black, one side was white, and they were fighting, and Kirk was saying, "Well, why are you fighting? You both look the same." And they said, "Don't you see? He's black on his left side and white on his right side, and I'm black on my right side and white on my left side." And so that's why they were fighting. Kind of very interesting episode on race relations. Here's a closer look at IAPETUS, and we can see that it has some other interesting features. It's got a scarp-like bulge around its equator here. And why has that? Let's go back. It is still a curiosity, this scarp-like bulge around the equator. Closer look at IAPETUS. PHOEBE. PHOEBE is Saturn's only moon to orbit retrograde. All the other moons are orbiting prograde with the planet, suggesting that they might have formed with the planet. PHOEBE does not do that. So it's very likely is a captured asteroid, came in afterwards, and giving it a opposite orbit to the other moons. So here's an interesting closer look at PHOEBE showing impact and ejecta on these craters. Very nice picture. And those craters in 2005 were named after Jason and the Argonauts. So the major craters on PHOEBE have names to them. And if you sent your $50 in, you possibly could get your name on one of these craters like I did. Here's the Golben crater right there. Only $50. Best $50 I ever spent. No, you can't buy your name on a crater. Wish you could. New moons are being discovered all the time, especially around Saturn. Like I said, the number of moons have doubled in the last couple of years. And here, this tiny little dot over here is S2007 S4. It's so new that it doesn't even have a name on it yet. But it's just that little dot seen in this time-lapse pictures going around Saturn. At some point, you have to decide what is a moon and what actually is just a little rock out there. Here are the moons of Uranus. 27 moons around Uranus at latest count. Just about half as many as around Saturn or Jupiter. 10 of those moons were discovered by Voyager 2 in 1986. Many more now being discovered by the Hubble telescope. Uranus has no large moons, but it has several medium-sized moons. 5 of them, in fact, in circular, tightly fixed orbits around Uranus. Those moons are Miranda, Ariel, Umbriel, Titania, and Oberon. Here's a look at Titania, Uranus' largest moon. Very nice picture. Here's Oberon. You can see some crater impact, some ray ejecta, similar to the other icy moons that we've seen. Here's Umbriel. Again, hard to tell them apart. You got these icy crater-like impacts. And as we look here, we have Miranda. Not necessarily one of the bigger moons of Uranus, but one of the more interesting ones, because its surface is just a collage of different interesting surface features. It looks like it is a jumbled puzzle that was put together later on. So maybe it fractured, went into many pieces, and these pieces coagulated back into a moon, but hence each had their own significance, ridges, valleys, faults, grooves, and cracks, making it a jumbled 3D mess of a moon. And all this collage of different features in this one moon. So it's been through a very violent, catastrophic past. Now look at Miranda. Neptune has 13 known moons, about half as many as Uranus. Again, the number changing almost daily. Largest one being Triton, as we've mentioned before. Here's Triton, largest moon of Neptune. The smallest of the 7 quote-unquote large moons in the solar system. Probably a captured object from the Kuiper belt nearby. 1/3 of the mass of Earth's moon. Has a thin nitrogen atmosphere, and a surface temperature of 37 degrees Kelvin. Similar in size to Pluto, and similar in density to Pluto. So it suggests that maybe they are both of the same type of material, both KBO. So if we're looking at Triton in these pictures, we can imagine we might be looking at Pluto as well, at least in terms of comparison. Triton does have some interesting surface features, though. It's got this terrain similar to the tectonics that we saw on Ganymede, and it's got some color to it. It's tilted to the equatorial plane of Neptune by 20 degrees and orbiting retrograde around Neptune. So it's the only large moon to orbit retrograde around its host planet, helping to suggest that with this angle and the retrograde motion that it was indeed a captured object by Neptune. Eventually it will spiral inward towards Neptune due to this retrograde orbit, making it eventually break up when it falls within the Roche limit and form a icy ring around Neptune. So maybe Neptune will be a very pretty planet with a ring system someday. We might have to wait a long time, a billion years, but who's counting the days? I can't wait. Here's a look at the surface of Triton. Relatively new surface due to the ice flows on Triton, and it's got geysers of liquid material. So frozen lakes of ice and geysers throwing out some form of liquid, most likely liquid nitrogen or ices of that sort, liquid nitrogen and maybe oxygen. Geysers and polar caps of nitrogen frost, ridges and gashes, giving it a cantaloupe-looking terrain. Probably not oxygen. That concludes the second lecture on the Jovian moons. Our third lecture in Chapter 8 will cover the ring systems and Pluto and the KBO objects.